All right, here we are. It's a new day. I'm wearing my, I think, uh, Bird of Paradise shirt here from my old man Tommy Bahama collection. I think you all need to see this. So anyway, welcome, welcome. It's a new day, and there we go. My wife was like, That's for someone huge," and I was like, "Well, I'm huge." Anyway, I I accidentally erased what I did on this last time. So let's talk about density. Density we've already talked about before. You figured out the density of a baseball in your last problem. Okay. Um, and so density is the mass of an object divided by its volume, P over V. So here we go. This guy, physics professor Ray Palmer, discovers a white dwarf star fragment. And it's the missing ingredient to his miniaturization. All right. Well, first of all, he picks it up. Let's say he picks up this thing, and according to our astronomers, we're going to see something kind of funny. Assuming the white dwarf fragment sphere is with a radius of 6 inches. Okay. So mass. Oh, we're going to remember this guy because we're going to do this with a beach ball, not a white dwarf star. Is the density of the object times the volume. Okay, mass is equal to the density of the object times the volume. And here's the volume of a round object, of a sphere or a ball, 4/3 pi r cubed. So we figure out the 6 inches, about 0.15 centimeters. So look at the mass of that thing. The density of a white dwarf star is 3 million kilograms per cubic meter. 3 million. So we look at the density, we look at the mass of that thing, that's 44 million kilograms. I don't think you'd be picking that up. In fact, astronomy has such crazy, I mean crazy, huge and crazy small numbers that they use a thing called an earth meter. I'd almost want to show you what, but I'm getting off track here. But an earth meter is what they figure is if you took the entire earth and smashed it down into a 1 meter by 1 meter by 1 meter volume. That's the density that they use. Okay, so it's incredible. All right. Anyway, but we're going to do this. We're going to do this mass times volume thing later. So it has the weight of about 650,000 150-pound people. All right, or a million babies, one or the other. All right. So anyway, floating. Another density objects float as long as if the density is lower in some fluids. Soda can. I wonder which you could do this. You could do this in your bathtub or in an aquarium. Take a Diet Coke and a regular Coke, put them in the bottom, see which one floats to the top. I think it's the Diet Coke is less dense because it's got different chemicals in it, that aspartame that's in it. Okay, gas is sealed in a frictionless piston. All right, this means it's able to, I'm going to put myself in the corner here so that you can see me. Tommy, can you see me? Anyway, so I just put myself up in the corner so that you can see what I'm talking about. All right, so you got this little piston. All right, you got the, and what we're talking about is it's in a container that it's able to go up and down. All right, you got a top on top of it, but the top is able to go up. Well, it's kind of like this guy. It's kind of like this hand cream thing, but this able to go up. All right, so it's able to expand. The gas is heated and expands in the cylinder. So if you get more, so you're going to get more volume. So if you get more volume, then therefore, if you get more volume, then you're going to have an increase in density, remain the same, a decrease. You're going to definitely have a decrease. All right, go ahead and watch the here in a minute, watch the sulfur hexafluoride things. They're kind of funny. And helium is a lot less dense than air. And so now the guy in the Mythbuster said it's 6 times more dense than air. Okay. It's it's 6 times. That's a picometer. Picometer is the distance between the fluorine atom and the sulfur atom there. And yeah, there's all kinds of neat experiments where they float boats and stuff like that. As a matter of fact, I'm gonna take a detour here and we're gonna watch one. All right, we're gonna watch one. Floating aluminum foil boat. Watch this. This is kind of cool. Yeah, here's one, 30 seconds. There's nothing in there. There's nothing in there. What's going on? Is that there? This is kind of funny. Okay, so actually, what's kind of funny is what happened. I don't. Okay. That. And let's get back to the slides here. Sorry, so there's the floating boat thing. That's kind of cool. Now, what was happening? What was happening there when it So when it started to sink, here's what was happening. When it started to sink, he wasn't pouring the fluid in there. The hexafluoride was dissipating out into the room, so it was dispersing out into or diffusing actually throughout the entire room, and so the sulfur hexafluoride was leaving, and so it eventually. But he kind of did that little magical looking thing, so that's kind of cool. So I've got a few other videos of where they're talking using it.
I promise to show you something really cool as long as you promise not to try it at home, okay? Okay. Now, everyone wants to know why my voice sounds higher when I inhale helium. Well,
first of all, this stuff's very expensive.
My simple fact is that helium is 6 times less dense than air, which means sound waves travel through it much faster, which makes my voice sound much higher. Now, the same effect can be achieved in reverse if I inhale something like
sulfur hexafluoride, which is 6 times denser than air. I inhale some of that, and my voice gets really low, although somehow I'm still funny. It's scientific!
Okay, so that's pretty good.
Imagination station.
All right, and then there's so the different does it cause you to talk with different frequencies. Okay, so a lower frequency, lower frequency because the sound wave is probably going to stay about the same. Lower frequency, deep voice, higher frequency, high voice. What if the planet? Now, this is one of your questions on your little homework. What if there's a planet that is identical to Earth, but its atmosphere is made entirely out of sulfur hexafluoride? Would it be greater than? Would the pressure be greater than? Less than? Equal to? Okay. It's exactly like Earth. So it's got the same volume, but the density is 6 times. So that means its mass, it's 6 times more massive than air, which is mostly nitrogen and oxygen. Mostly nitrogen. Much more massive. Gravity pulling on it, it's going to be greater. Because again, rho GH, that's pressure. So if you go way underwater, the William Trowbridge stuff that you did in the last assignment, same type of thing. Hot air balloon, invented in France. Hot air rises. Here's a cool experiment of that. Watch this. Oh, let's go to here. Teabag experiment.
following experiment will show you how to make a tea bag fly using convection. This is similar to how a hot air balloon works.
Whoa!
First, you're going to need some tea bags, matches, scissors, and tinfoil. Take your tea bag and cut the end off of it as shown.
Oh, sorry.
Then, open the tea bag and remove the tea from inside. Now you should have a cylinder made of tea bag material. Place this cylinder on top of a piece of tinfoil or something else that won't burn, and then use your matches to light the top of the tea bag. As the tea bag burns, it fills with hot air. Since hot air rises, the tea bag flies up into the air.
I saw a really funny one on this where looked like some kids were like in a trailer somewhere doing this thing and filming it, and I was like, oh my gosh, where are the adults? Anyway, so I don't see it over here. Maybe they took it off. All right, and then of course the ultimate thing to do is use helium, and this is the cluster balloon thing. Then I'll stop this little. Uh-oh. Error. Better stop here. And we'll move on. A little bit. Sorry.